Good morning. How is everyone? Is that loud enough? Is it too loud? Sounds really loud from up here. All right. So what do you think of Raleigh so far? Oh, I was a little tepid. I've lived here 15 years, and I got to say, I love every aspect of Raleigh. I'm very pleased it's my home, with one exception. The allergies down here to my northern blood are a little daunting. Which is kind of interesting. You think about it. You take something out of context, take my Yankee blood cells and bring them down here to some southern pollen, and you get a little bit of a problem. And that's actually what I want to talk about first. Not my allergies per se, but the things about taking things out of context and the importance of context. So we'll start off with a quick little game here. Can you spot what movie this description comes from? A man's wife is brutally murdered by a serial killer and his son left physically disabled. Then, in a twisted turn of events, his son is kidnapped and he has to chase the kidnapper thousands of miles with the help of a mentally disabled woman. Can you? Yes! Finding Nemo, right? Now, it's a completely different, that is the story. That is factually correct, but you get a very different flavor from that description than the happy little Disney fishies, sort of swimming around there. You take it out of context, you get a very different idea about it. Here's another one. Transported to a surreal landscape, a young girl kills the first person she meets and teams up with 3 strangers to kill again. Right, Wizard of Oz. It just sounds a whole lot creepier that way. And this is the problem when you see or take things out of context. You take something that's perfectly natural, perfectly fine to have, but in the wrong context, you get the completely wrong idea. So, for instance, an axe is a very helpful tool. You chop things down, it's good for woodworking, all this, but you really shouldn't carry it when you're hitchhiking. Folks might get the wrong idea. Similarly, if you go to the bank or doctor's office, I love those little bowls of free candy they have out, with the sign, but if you put that same sign on the side of a kidnapper van, not really what we're trying to convey. So what happens is a lot of the times when we're working with something, working with code, working with a team, an organization, something like that, we have a tendency to distill what we're seeing into overly simplistic objects in our brains. So, for instance, if I asked you to think of a tree or draw a tree, you'd probably do something like this, which is the culmination of my artistic talent, which is why I'm a programmer instead. Well, the problem is, we mentally think of trees as objects. It's a thing. It sits there on the ground all by itself, and it's got all its parts, leaves and branches and trunk and whatnot, but we think of it as a separate thing. And that's the danger. So what a tree really is a set of interreacting systems. It's not an object at all, per se. It's a meeting point of a system that involves respiration and carbon dioxide and the leaves and photosynthesis and the sun and the roots and the nitrogen and Krebs cycle and all these things I don't remember from high school biology. But it's a very active, moving thing, and each of these systems interacts with the next system on up the line. So this is a very important lesson from the idea of systems thinking, which was popularized by Peter Senge in the book The Fifth Discipline back in the, 80s or so. And it's a very important ability to be able to look at something, a software project, a team, an ecosystem around a language, whatever it might be, and view it as a set of interreacting systems. Because tied along with this idea, once you begin looking at things as systems, you realize they're all connected. It's like a giant spider web, and you flick one little piece of the web, everything gets perturbed to some degree. Now, by the time you get out to the very end of the web, your actions as an individual might have very little effect farther on down, but it does have an effect. Things can amplify and dampen, and it is all connected, which means if you're having a bad day, your code's going to have a bad day. Your project's going to have a bad day. Your team, your organization is going to have a bad day. It's all connected. And so this changes a little bit how we look at project management, how we look at software development, once we begin to realize the extent of systems thinking here. And a lot of times, even just looking at a model a slightly different way in a different context can be helpful. So, for instance, everyone had to make a little solar system model in grade school, right? You put all the planets up on a foam board or you hang them on strings, and this is a new one. Poor Pluto got kicked out. He got Plutoed. He's gone. And we're sort of used to thinking of the solar system this way, the model with the sun sitting here and the planets all spin around, and that's kind of boring and wrong. That's actually not what happens, because the sun is whipping around the galaxy at the same time, and the planets are going around it. So what really happens is more of a vortex model. Now, this is the same thing. The sun's whipping around the galaxy, and the planets are whipping around the sun, but this conveys a much different feeling. We're going places in this model. We are whipping through the cosmos. We're not just sitting there coming back around to the same old spot every year. We're going somewhere. Don't know where, but hey, at least we're in motion. It's a good thing. So, again, just changing the context and you get a different idea about it. Now, I harp on this a lot because one of the more, I think, probably major discoveries in neuroscience kind of hinges on this. For many years, it was taught and thought that you achieved some maximum number of neurons in the brain, and that was it. So if you killed off any neurons from, say, scotch or beer or wine, then this would be a net negative. You're killing them off, you ain't getting any more, you're in a heap of trouble. And this was the prevailing scientific thought for good 20, 30 years, something like that. And it turned out to be completely wrong. And there's two interesting facets as to what it means from it being wrong and why they got it wrong in the first place. So why did they get it wrong? They were studying primates in laboratory cages, not in their natural environment, not in their original context. And the truth is, if you put a primate in a sensory-deprived cage, not unlike a modern cube at work, you don't grow new neurons. There's no need for it. There's nothing to handle. But if you put the primate in their original sensory-rich environment, then they do grow new neurons. They reconfigure the brain, they re-specialize what needs to be done. All this kind of stuff happens. So first of all, if you study something out of context, you're going to get the wrong results. But the positive side of this is you do grow new neurons as needed. Your brain will reconfigure itself as needed. It is a self-modifying machine. And there's this constant sort of battle for cortical real estate going on in your head. So if you're a musician, you're going to have some percentage of your brain dedicated to scales. If you're a London taxi driver, you're going to literally grow extra brain cells to handle the local maps of the London area. This is what happens with repeated use and practice. Oh, and it cut the caption off. The caption says, "Lost the battle for cortical real estate." And that happens too. It's very much a case of if you don't use it, you lose it. So your brain is a self-modifying machine. What you think about the brain and how you think it actually affects how the brain behaves. If you think you can learn an unlimited amount, then you can. If you think that no, you were born smart or stupid or whatever, and that's it, then that will become a self-fulfilling prophecy because it's your brain doing the thinking and it's doing the wiring. So it's kind of all tied in there. Why do I mention this? Well, back to open source, since this is an open source conference. I've used open source since at least I guess since the early 90s with Slackware when that first came out, and probably earlier with Emacs and GCC, as luck would have it. And it's kind of fun to see through the years. I mean, in the old days, X modem was a big deal. It was public domain, but that was a really big deal. There wasn't a whole lot of open source around. I mean, there was stuff, there was Pockets, there was Emacs, there was GCC, there was whatever, but it wasn't anything like what we see today. The bottom here is a little bit cut off, but we go all the way down to open source hardware, starting with Arduinos and Raspberry Pis, up through operating systems, databases, web servers, frameworks, new languages, old languages, you name it, all the way up to UI layers that everybody uses for new websites. I mean, it's not a stack anymore, right? We used to talk about LAMP and sort of web technologies as a stack of technology. No, a stack is like a little couple bunch of pancakes. All right, this is not a stack anymore. This is a tower. This is a phenomenal tower that reaches all the way down from hardware to UI and everything in between, with new stuff coming out literally all the time. So it's a kind of a comforting cliche to say, one of the great things about open source is that we're standing on the shoulders of giants to be able to create new works and new projects and whatever. And that's true to a degree, but more important, I think, we're standing on everyone's shoulders. We're standing on each other's shoulders and then leapfrogging along. It is an incredible time in human history, your ability to use all this software for free, to learn from it, to improve it, and to move the industry forward. It's all right there. There are fewer barriers to learning right now, probably, than any time in history. Any tech topic that you want, any worthwhile language, library, technology, you can get all the experience you want with it. Just start playing with it. You can get feedback from your peers on forums and user groups, mailing lists, what have you, local user groups. It's almost an embarrassment of riches. All this cool stuff that you could learn. It's like, wow, I've always wanted to learn functional programming. Well, what's really stopping you? Nothing. You can grab something like Elixir or Erlang and Clojure and dive right in. And this is a bit of a problem. So one of the things that we mentioned back in the original Pragmatic Programmer book, back at the turn of the century, God, it sounds so bad, is this idea of being very deliberate about what you want to invest in and what you want to learn. If there's something that's kind of driving you, that you need to learn it, be very deliberate about it. Start with a plan. Say, what do I want to do immediately? What do I want to download? What books do I want to buy? What courses do I want to look up on YouTube? What have you? Where do I want to be 6 months from now? Do I want to get a job in this? Do I want to come and speak at a conference like this on that topic, and a year out, and so on, with very concrete time-box goals? I'm going to get the Elixir book, and 1 week in, I want to write a robust server that does whatever. I'm going to study Node, and I want Node to be able to pull from all these sources and do this for me, whatever it is. And as you're going about this, and this is just a great daily habit, we always stumble across things that kind of bother us. It's like, I always get this error message, and I don't really know what it means. Or we always have to use this piece of technology to band-aid this piece of technology, and I'm really not sure why. Find out. Go down that rabbit hole. Google for it. Ask around, check into it. How does Node work? What is the big deal about Lisp? Anything that's always bothered you that you don't know, you can fix. You can drill down and find it and fix it at this point in history better than any other. But then, of course, I have to give a bit of a cautionary tale. At the end of the day, it's not the technology at all. It's what you do with it. And this is how you can have commercial companies based on open source frameworks and platforms, because the tech itself, you can get a little advantage here and there, but at the end of the day, does it matter if this company has a better web server than you do? At a certain point, once you've got high performance and everyone can get high performance web servers and a common base level of technology, the tech doesn't matter. It's commodity. It's what you do with it that matters. So one of my seasonally appropriate hobbies, we always like to build a good haunted house in the garage for the kids. Now, of course, being a hardcore geek, a haunted house in my garage involves Arduinos and Raspberry Pis, relays, pneumatic powered jumpers, ultrasonic sensors, multiple distributed audio channels for screams and shrieks and all this sort of stuff, all based on open source hardware and off-the-shelf parts. And the cool thing is, you take some standard parts and a couple props and whatnot, and you create something really very different. Something really quite unusual. And this is what we do for fun for Halloween. But that's the same sort of thing. For a company, you have this wonderful base, this framework to operate on, and then do whatever. So this is the question I put to you, attendees of this conference today. What are you going to learn? What are you going to learn today? What sessions are you going into? Why? Is that the best session you can go to? What are you going to do with it? What are you going to invent next? And this, to me, is where the agile software movement kind of fell down. Now, the Agile movement, as you know, really kind of came together around 2001 with the Agile Manifesto, where some 17 of us got together with the leaders of extreme programming and Scrum and Alistair Coburn and his crystal methods and Jim Highsmith and you know, all the folks. And so we all got together to chat about this kind of stuff. And as the 10-year anniversary just came up a couple of years back, a lot of folks would interview me and say, hey, you know, it's been 10 years. What's your take on where the agile software development has taken us and this sort of thing? And one thing that I found really interesting, looking back at my original notes from that period, which I took longhand in an actual notebook, one of the things I noticed was that all of us at the time had this expectation that having laid out these sort of ground rules, that this is what defines an agile method, there would be an explosion, a proliferation of agile methods. Every consultant and his dog would come out with their own take on what an agile method should be, and there'd be this sort of great flowering. And it didn't happen. What happened was everyone's like, oh, look, here's XP, we'll kind of do that. Here's a bit of Scrum. We'll do most of Scrum, but not the parts that make us uncomfortable. And you know, we kind of go from there. And that's sort of where we are today. We never saw this kind of blossoming of people adding their own inventions to the mix and propelling the industry along. And the situation is better on the coding side, I think, in the open source world. I mean, if you count the number of gems going into the Ruby repository or any kind of similar metric in other languages, there's a lot of stuff getting thrown out there. A lot of it can be garbage. Some kid's school project that was sort of fun and he's not really going to support. And now and again, you get these real, true gems, real functional, wonderful stuff coming out there. But I think we still need to see more of that. Elixir, if you haven't heard of it, is a new language. It's coming out as we speak. I think the first formal version is due out probably spring or so. And it's interesting and exciting. And to me, it's really the first interesting or exciting language I've seen in too long. And we've had other new-ish languages come along which have kind of interesting aspects, but overall it's like yawn. It's the same old. Where's the fantastic inventions? Where's my jetpack? This is what I want to see. So what I want to leave you with today is just a really quick maybe starter guide to where the next big idea could come from. And I'll skip ahead to the end. The next big idea comes from you. Right there, sitting there, right there. Each one of you. That's where the next great idea comes from. So that's what I want to talk about on our way out here. Where particularly does it come from? Well, it comes from your brain, but not all of your brain. It turns out the kind of things, the insights, the flashes of inspiration that we really want come from a very particular set of processes across the brain, which isn't under conscious control. It's very difficult to say, okay, I need some inspiration right now. I need a flash of insight, boom, right now. It doesn't work that way. It's asynchronous. This is the same, well, it says asynchronous up there, but you have to trust me on it. This is the same sort of thing where if I asked you a trivia question like, what year did the first King Crimson album come out, or something like that, assuming you know that, it may not bubble up immediately. So you'll be out doing the dishes, mowing the yard, stuck in traffic on 40, and boom, it pops into your head. So that's what I'm talking about here. We've got these sort of pre-conscious processes in the brain that are asynchronous. They will deliver their results whenever and not under conscious control. These areas of the brain are very fragile. If you've ever had the experience of waking up from a vivid dream and you try to explain it to someone, as soon as you start putting the dream into words, what happens? It starts to dissipate. It becomes harder and harder to access those memories. There's reasons for that, but for our purposes here, this just furthers the idea that these are very slippery, fragile, difficult kinds of thoughts to deal with. So that's what we're kind of up against. Now, who gets these sorts of wonderful insights and flashes of inspiration? Well, everyone does. And I truly mean everyone in the whole world gets a great, billion-dollar ideas before lunch. The problem is, very few people bother to keep track of them. It's just part of the river of effluvia of the daily life. Oh, wouldn't it be cool? Somebody should invent something that does and then you go on with your day and nothing ever happens to it. So the first thing you want to do to come up with the next great idea is capture it. When you get that magical flash of insight that's flitting by like some kind of a crazed bird or a butterfly or something, you need to capture it. Now, there's a bit of a problem here. You are most likely to think of something really creative and inventive when you're not in front of your computer. And the corollary is true too. If you're trying to come up with something very creative, you're stuck trying to fix a bug, you're trying to fix a design, you're trying to come up with the next great sales plan, whatever it might be, the worst place you can be is in front of the computer. It turns out that while you're sitting there typing on the keys, involved in that kind of symbolic reduction and symbolic processing, that actually chokes out the kinds of mental processes in the brain that we're trying to harvest. They're not really compatible. This is why you may have noticed, if you're stuck on some hard problem, you get up, you walk away from the computer, you're headed to the restroom, you're headed out to the car at the end of the day, and what happens? You're halfway along the walk, and boop, all right, the idea comes to you. Oh, I know what it was. All right? This is what it is. You don't want to be in front of the computer. So this poses a bit of a problem. You're not with your computer where you can type in this great idea, this insight, this question that you have. Gee, I wonder what. So what do? Well, carry something with you all the time. Something like a notebook, index cards, an iPhone, a cell phone. I see little pads coming out here. That is the thing. That is a dollar bill. That's not what I'm looking for. Hold on here. Here we go. That's from parking out there. I always carry just a little cheap notepad and my Fisher Space Pen. This is the one that, yes indeed, will write upside down in a boiling toilet should the need arise. I've never tested that. I've used that joke for 10 years and I still have not tested it, but one of these days. And the idea is you want something that's with you all the time. So when you get that little niggling, gee, I wonder what, you can jot it down. Because if you try to commit it to memory, you're going to forget it. You're going to distort it. Human memory is crap. It doesn't work very well at all. It's not reliable. Don't rely on it. You can do some other fun things, like if you're driving and you're using your approved hands-free cell device, you can call and leave yourself a message, and if you've got one of those transcription services, like I've got one, I forget, it's Vonage or Uma or something, but Google Phone, it goes through and you get an email with the text, voice to text sort of transcribed. Then you can just get back to your computer, cut and paste, and you've got your notes. Hands-free. Very cool. But whatever you do, you want something with you at all times to sort of capture these random ideas. Then you need to work them. And the best way to do that is with a mind map, sort of like we're drawing here. Once you start even just making categories for a kind of a thought, your brain will tune itself to see more of them. It's related to a phenomenon in psychology called sense tuning. And once you start looking for something, you'll see it everywhere. In other speakers' sessions, in mailing list threads, on the web, whatnot, you'll start finding the things that you're looking for. By drawing a mind map freehand, like this on paper, you can nurture the ideas, you can play with it. There's no constraints, it doesn't go in order or anything. You just write it wherever it needs to be, draw big lines across it. And as you work with it, this is the key part. You start to see associations. You start to see new relationships between things that you may not have noted before. Oh, this might have something to do with this over here. And that gives you something to work on. And that is where the brilliant creativity comes from, is in looking at what is already there and seeing relationships you hadn't seen before. That's really the secret. The key to working with this is to leave this open, because these ideas come asynchronously. You leave this out on your desk, eat lunch over it, and as you're doing whatever in your normal workday, ooh, I had a thought. Boom. My kids tease me. I'll be in the middle of a conversation with the family and suddenly go quiet and start writing something like, oh, Dad had a thought. But it works. Your ideas are in there. We want to harvest them and get them out. This tower of open source tech is there for you to use. What are you going to do with it? Thank you so much for having me today. It's been a pleasure. Have a great conference.